So you're almost done your breakfast. Huh?
Yeah. Actually, I have something that's on my mind with our chain lately. I'll show it briefly, fly by that real quick. I think I put it in one of these proposals, which has fallen off the bottom. Interesting. Basically, you can't, staking pools are kind of impossible. You can't stake with a smart contract. You can't, but I thought of a solution to that. And where'd it go? Well, maybe I knew I raised it, so I could do author, me.
It's interesting. I was also thinking about how we would do staking on the RoBetNet shard, and was trying to think how we could do it dynamically, and this seems like part of the answer.
Right. So I'm staring at things. So we have this RStake project over here, which Gary was involved in, God rest his soul. And we were thinking, you know, we started the contract in English, but we expected to move it to Rolang in due course. So I had been digging around saying, okay, how would that actually work? But the only way you can bond in our chain is with one public key. And so all of the rewards go to the rev address corresponding to that public key. And I thought, oh, well, if you could bond with a rev address, then we could use one from Unforgeable that is from a smart contract, and then the rewards could automatically be divided up. So that's the problem statement, right?
So an Unforgeable name has a rev address?
Well, it can. Oh, yeah. There's rev address from Unforgeable. That's one of the standard methods.
Ah, okay.
Yeah, that's how you send money to a smart contract. Okay, so that was my problem statement. And Tomislav says he basically says you really do have to have one public key to participate in the proof of stake protocol, because you have to sign blocks. And then I said, okay, well, then perhaps the bond method could take a public key for signing blocks and a separate rev address for rewards. Does that make sense?
Yeah, I guess I lost the justification.
Okay, so I would like to when the rewards come in, I would like them to go to a smart contract so they can get automatically split up, right?
Right.
Right now, when you bond with a public key, and the rewards go to the rev address corresponding to the public key. So that cannot be a smart contract.
Right.
It's a rev address from public key, not a rev address from Unforgeable. And so Tomislav says, yes, you absolutely have to have a public key. You have to bond with a public key because that's the public key that's going to be signed, that's going to sign the blocks, right? I say, fair enough. So suppose we give both a public key and a separate rev address. In other words, here's the public key I'm going to use to sign blocks, but when I get rewards, please send them to this separate rev address.
Right. It seems very doable, right?
Yeah. So there's hard forks coming up, and I believe they're working on the smart contracts at the bottom of, you know. So that seems kind of important. But it has sat there since September 18th. So
I see.
Maybe you want to nudge it along.
Yeah, you assign me.
Yep. No, I can't. I can say, hey, Jim, use getting this into one of the upcoming into the POS contract in time. One of the
And that's, you know, that's really a tech governance issue, but I think, let's raise it now. And next Friday, I think we can probably make a decision.
Cool. Right. So that was the thing I was thinking of there. And then, as I mentioned, I am hip deep in, well, this is some, I'm hip deep in two things. I have to deal with Mark Miller's comments on my documentation proposal. But this is the Agoric Discord, and here's IBC. Well, I guess we can sort of transition. Go back to here and author Dan Conley, and oh, here. Oh, what happened to my mouse? Oh, I wonder if my battery's going bad or something. It just freezes up every once in a while. Let's take the battery out, put it back in. No joy. Oh, okay, now it's back. Okay. In most of the popular blockchains I know of, there's a light client specification, a way that a client can verify any transaction given a recent block header and a Merkle proof. Does our chain supply something analogous? And there's a, oh, it's not down here. Tomislav has talked about it, how they might do that. But the answer to this part is no. So the transaction server, come on, my mouse. Okay, hold on while I get a battery for my mouse. Okay. Right. So we have this transaction server that shows how to find the rev transfers from COM events in our chain blocks. Because an R-chain block is a bunch of COM events, basically. It doesn't, a Bitcoin block is a bunch of transactions. And likewise, an Ethereum block is a bunch of transactions. And the basic transaction is send this many tokens from there to there. But in our chain, that's not the base unit of work. The base unit of work is a COM event. And so our chain blocks are a bunch of COM events. And so making a send this many tokens from there to there is some number, you know, it's 10 or 20 COM events or whatever. And so you have to search through all those COM events to find things that look like transactions. So I believe that's what this transaction server does.
Sorry, what do you mean by transaction? When you say transaction, what exactly are you talking about?
Send this many tokens from this address to this address.
Just that?
Yeah.
Okay.
So in our chain, to do that is about 15 lines of code. Rolling examples, vault demo, transfer funds. So when this is how you transfer from to and this many tokens. And in order to do that, there's a send there and there's a send there. And, each of those is going to result in COM events, right? So you can then go back through this thing and find COM events that follow that pattern. I believe that's what this thing does. So you can find the transfers in our chain blocks. And I was wondering if we could then do this Merkle proof thing where you say, okay, I've got the hash of the block and a path from the block back to those things. And now I could tell that the transaction happened without having to have the whole block. Anyway, so that's not possible currently, but they've talked about how they could do it. then, okay, then there's this IBC relayer diagram. So this is how IBC works. And it's a relay in one direction. You can run no. Well, it's directional. The packets go both ways, but I guess A and B are slightly different at connection time or something like that. So it's important to distinguish A from B or whatever. But like I said, there's a light client there that's listening to chain A and saying, oh, I see a signed block. I will go look for IBC packets inside that signed block. And if there are any, I will relay them to chain B. And likewise, this thing's listening to chain B and looking for IBC packets, and if so, relaying them over there. All right. And why is there a B key store? And all this stuff here is connection setup, I think. Query by topic. Anyway, there's some details I don't, oh, what is this? Connection B to A. Oh, right. So there's a number, there's connections back and forth, and then there's channels. So anyway, then you send things across channels. It's a little bit like TCP IP inside the blockchain connection. Okay, so that's how IBC works, and that it actually you can send sort of generic packets, but it also has a thing called ICS-20 where you can send basically ERC-20 tokens back and forth, except that this is not Ethereum, this is Cosmos. So that's as shown in this diagram, a light client for each blockchain is needed in order to relay between them. If we had an R-chain light client, we could use IBC to participate in Gravity, a bridge to Ethereum. See also cross-chain peg. Yeah, I can show you the peg contract in Agoric that pegs tokens between chains. It's like 50 lines. It's pretty cool. Anyway, and oh, right, that was in the RStake thing. So that was me asking, can we do IBC? Because if we can connect to Ethereum.
Yeah, I think you do a lot more. I think we could implement remote channels the same way.
Yeah, you can do cross shards. You could just use that for shard to shard communication in our chain.
Absolutely. I
Yeah.
think that you know, this is something I think is important. I don't know why Red keeps putting it off.
Yeah, but you can do shard to shard in our chain without doing channels and well, anyway, you might end up rebuilding IBC eventually, but you could do it. You might be able to do it a different way that might be less engineering work, but you wouldn't simultaneously get connection to all these other chains. Oh, this is kind of cool. That's the test net, but because I've been playing test net, but this is all the existing IBC traffic. So these are all the Cosmos blockchains talking to each other.
Sweet.
And statistics about it. And if you turn it to testnet, which is where I've been playing around, there's even more. There's a bazillion of them. So that's mapofzones.com. That's kind of fun. Yeah, so if go ahead.
That would put us on the map there.
Yep. Yep.
Awesome.
Oh, and one of those does oracles, by the way.
Yeah, well, I'm thinking oracles. You know, this is the way to do them.
So where's band? Oh, they're not. Yeah, there.
You know.
Let's see if they're in production. I saw the governance vote go through to put them in production. Oh crap! They don't. Well, maybe they're just. But I bought some band thinking it would go up on that band protocol. So it's a cross-chain data oracle protocol. So it's a Cosmos zone that will, let you look up the weather in Zimbabwe or the price of this or whatever. Okay. So I discussed that with Tomislav in April, and I asked him to jot down what he remembered, but we didn't manage. But he did follow up and ask Greg about it. What's this? I can't remember. Anyway. Okay, but in the tech governance docs, we were talking too much to take notes. Anyway. Cross-shard interaction. What's this? Hardship proposals. Oh, yeah. So you had a similar proposal about cross-shard interaction, and I think I said, oh, yeah, you might be able to do that with IBC. And by the way, IBC is a layer below capTP. And I'm going to preview this. You don't have to understand the whole thing, but the 4 tables, they look, this is the visual diagram of it. So you got Bob's VAT up here and Alice's VAT down there.
Do you make that a little bigger for the video?
Yeah. So where's the example of actually doing stuff? So there's the 4 tables. They're like questions and answers, incoming and outgoing. It's sort of how you get 4 tables. There's videos where he walks through the capTP stuff, but basically you say, okay, how tall is it, or what's the value of the purse over there? And so when you send that, you don't have a reference for the purse yet. No, you must have had a reference if you can send the question. Well, it's something like Alice or Bob says, oh, there's a purse. And so when you hear about it, you call it object 1. And then you say, oh, what's the balance of object 1? And then when Bob exported it, he didn't necessarily call it object 1. He called it object 12 or something. But when it comes in, he says, oh, object 12. No, you have to refer to it by the number that Bob knows. Okay, so anyway, how it works, we'll have to find the relevant video. But there's 4 tables that are involved in being able to keep object references that go across VATs. And just when you capTP, you can send a message with arguments, and if the message is just strings and integers and stuff like that, you just send them as is. Well, you serialize them somehow. And then otherwise, if they're objects, then you put them in another place, so that all the messages that go across have plain data and a list of the capabilities referred to and then you translate the incoming and outgoing numbers between numbers, and for example, on our chain side, they would be unforgeable names. And so it says, okay, when it refers to object number 1, that means unforgeable name 7, blah, 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 or whatever. So, and then, but the step-by-step of how you do that is kind of interesting to walk through. But so just keep that in mind. That was supposed to be a short preview, and then hopefully the rest of it will become clear as I play around. So this is what the world looks like in Agoric. What was I doing there? But you can do stuff like, oh, maybe that all got resolved on the client side because that didn't take a network round trip. But if you, so Agoric names is a name hub. It's just a data structure for keeping track of things. But if I do agoric names keys, you'll see that I did that before. So you get
is this JavaScript or what is this?
Yep. Yeah. So that was a block round trip there. You get an unresolved promise, and then it goes to the blockchain, computes the answer, sends the answer back, and then it resolves the promise on the client side. And this REPL knows about promises. So it prints unresolved promises, and then when the promise gets resolved, it substitutes the answer. But and then I can do agoric names dot lookup brain.
What's the E again?
Right, that is notation for capTP roughly. It means I forget what it's something like remote object system dot send agoric names lookup brand. This E expression roughly means the same as this. So it means send to that thing with this method and these arguments.
Right.
And you get a promise for the result. So agoric names dot lookup brand. It's going to say, oh, it's not a function. This is not an object on this end of the world. You have to make a proxy for it, and then you can call methods on the proxy, and then they'll get proxied across the network, and the answer will come back across to wherever the other VAT is. It could be across the network or on the same machine or whatever. So that's how you do all asynchronous messaging in the JavaScript framework, and whether the asynchronous messages are in the same VAT or a different VAT or different blockchain or whatever, it's all the same. Yeah, this is me at the very end of the game of IBC trying to send money from the Cosmos Hub testnet to the Agoric testnet. So this is actually talking to the Agoric testnet or DevNet, that is. This is still current Agoric Dev 6. We recently respun the start.
So how can you send money between to another chain? I mean, there must be somewhere an escrow or something that you're using.
Right. Okay, so let's go through it slowly, because that's the end of the story. And you read make files, right, Jim?
Yeah.
So this is I don't think I can replay things without messing things up, but we'll walk through the make file here. And make files are topologically ordered. They're not, this doesn't necessarily happen before this, right?
Yeah.
Okay, so there's this thing called Hermes, God of Messengers, and that's the relayer software. So this is, yeah, IBC and Rust, and the CLI is the Hermes command line interface. Being a hunk of Rust code. Okay, so to get that in a Docker image, I think it's pretty straightforward, but for the recording, what the heck? It says, okay, go give me the Rust build tools, clone IBC RS, check it out, cargo build release, then you're done. And then switch over, and then basically this is in Docker, there's this nifty thing where you can have a whole world with all your build tools and everything like that, and then you can start over, and then just copy the results of your build into the start over world, and that way your production, the end result doesn't have all the cruft from the build tools. So this just has the Hermes binary, and then I had to have SSL certificates for, I don't know why, but it failed without them. Okay, so we know that's how to build a Rust binary inside Docker. Not very exciting. Okay, and that's where the Docker file comes from. Well, mostly, I guess I had it edited a little bit, so I guess I should version control that now. This was a TOML parser, but I didn't need that. I didn't end up using that. Okay, so we're going to use accounts. The relayer is going to use accounts on both sides. And this is the address on the Agoric side, and this is the address on the Cosmos side. And I did have to put money in both of those. So for example, to put money in the Cosmos thing, you post to their testnet faucet. Okay. I see a scrunchy brow.
Looks good to me.
Okay, I thought I saw a scrunchy brow. Okay, but yes, you have to put money in the account. The relayer has to have money to operate on both sides. And how the relayers get compensated is an open issue right now. Currently, they're running altruistically. All those connections you saw in here are running well. It's not entirely altruistically. This osmosis, for example, is an automatic market maker, and so they want people to bring tokens over, trade them, and bring them back. So they run relayers. It's kind of supports their business kind of thing. One of these is regen, by the way, which is carbon capture, soil quality, climate change kind of thing. We already talked about that. Okay, where are we here? Docker image, Docker file. Okay, so create channel. No, start basically needs create channel. I didn't say that in the make file because I didn't figure out how to get the make file to really do its thing where it will not do things that it's already done.
That's why you touch files, right?
Yeah, I don't know if it wasn't working or what, but I didn't, so implicitly you can look at it this way. So start depends on task create channel. So to create a channel, we need the Hermes config, we need the Docker image, we need the Hermes needs the keys, it needs the private end of the keys in order to sign transactions on both ends. And we need money in those accounts so that we can pay for deliveries. And then I'm a little fuzzy on this, but we have to create a channel. So you Hermes create channel, and then you give the chain ID of the one side and the chain ID of the other. And then, I wonder if I should have made that Cosmos transfer. Anyway, it's kind of like what you're doing on the port on the one end and what you're doing on the port. So this channel that I'm creating here seems to be only good for transfer, which is the token transfer. And then unordered, I don't know what that's about, but it was in the direction. So there you go. So, and then the Hermes config is worth looking at. So restore keys, basically this is 12 words or 24 words or whatever. And so that says, okay, put that stuff in your key store. Hermes config might be interesting to look at. This is the Agoric instructions, but they were out of date a little bit, so I had to look at these. Okay. Log level equals trace, so we're getting lots of logs. Clients enabled and refreshed true. Well, whatever. I followed the directions there. Didn't really know. Connections are enabled. Channels are enabled. Packets are enabled. And every 100 somethings, it clears something. I don't know. It's not filtering. Telemetry is not turned on. So telemetry is like how you can watch the relayer do its thing or connect Prometheus to it or something. I never bothered with that. Okay, chains. This is what you have to tell it on each side. This is okay. Cosmos chains have a chain ID. I think Rolang or our chain might have one somewhere buried in there too. RPC address is basically a port where you could submit either queries or transactions or whatever. It's kind of like the web API in our chain. And then there's also a gRPC API, just like there is in our chain. I don't know what this is used for. There's also a WebSocket thing. I don't know if our chain has a WebSocket thing. I hear about it every once in a while.
This is wonderful. I love it. WebSocket is the way that's just the natural way to do peer-to-peer.
Yeah. Yeah, I think our chain has a WebSocket thing, but they don't talk about it a whole lot. I think it's only exposed to the exchanges right now or something. Anyway, RPC timeout. If you don't get an answer, 10 seconds, bail or something. Account prefix. So this is what they call BEC32. I think, I don't remember. Anyway, this is a public key hashed, and then with a sort of chain system identifier at the front of it. So this one's a Cosmos address, and this is an Agoric address. So on this end, the account prefix is Agoric, and then the key is the one where this is where to find the money to do your business. Store prefix is IBC. I don't know what that's about. This is the most it'll spend sending stuff to this end, I guess. And that's the gas price to use, and the token on the Agoric side is called run, and so these are urun. That's 10 to the -6 run. Micro run. Gas adjustment. I don't know what that is. Clock drift. I guess allow up to 5 seconds of clock drift, and trust period 14 days. I think that's the bonding period or something like that. It has to do with you better connect every 14 days or you're going to lose track of who the validators are, and so then you're screwed up. You have to connect at least once every 14 days. Because yeah, that's the bonding period. Well, the bonding period is 21 days, but I guess it's 14 days for a little bit of safety zone. Trust threshold 1 out of 3. I don't know what that is. Then on the other end, Cosmos Hub Testnet is the chain ID over there. Here's how you talk to it. There's what the addresses look like. Here's where you can get your money, gas, trust period, blah, blah, blah. Okay. So it's kind of the coordinates to talk on either end, right? And so when I write Hermes here, that means Docker run and delete the container when you're done with it. Now these invocations of Hermes have to share state. So there's a Docker volume called Hermes home. So mount that at home Hermes inside the container. And Z is something I added when I was flailing around with permissions errors. I don't know if I really need it. Also mount the config file in there, and then run Hermes -C in the config file. So that's what it does every time we invoke Hermes. We talked about create channel. We don't really understand it, but we talked about it a little bit. And then after you've done a create channel, you can do Hermes start. And which of these is doing Hermes now? This one. So here we have a Hermes running, right? You have to nod out loud. I guess I could look at you, but it helps if you say, oh yeah, now I know what you're talking about. Okay, so you can see it going, oh, okay, I'm going to do this stuff on the Agoric side, and I'm going to do this stuff on the testnet side, the Cosmos side. It's subscribing to queries. What else is it doing? I don't know. Some of this is like Rust programmer trying to keep their head straight stuff. Because we got a lot of debugging. We got all the way traces below debugs. So we're logging everything. Maybe we're logging a lot more than you would in production. The info thing is probably what you would do in production. So successfully connected to WebSocket endpoint, blah, blah, blah. Failed to collect events. Failed to read from WebSocket. Closed without handshake. Oh, that was on the Agoric side. So then it reconnected. So the WebSocket thing falls over once in a while. That's to be expected. All right. Skipping client for blah, blah, blah. Oh, this was when, when you set up the channel, this is your prize. You get this text here. This is kind of important here. Connection 43 on the one side and connection 3 on the other side. Okay, so there's a bunch of stuff that you understand vaguely about how to operate an IBC relayer, right?
Yeah.
Okay.
I guess I'm a little confused as to how often you're running Docker. It's like you for each transaction that you're doing.
This just runs indefinitely. If I were doing it right, this would be a systemd service and it would just run forever. The relayer is always there because somebody may want to talk to the other chain at any time. Does that make sense?
All right, so this is basically just doing protocol conversion.
Yeah. Now this has got Cosmos on both ends of the thing, so there's no conversion. They're both speaking ICS-20, but it's doing transport. It's transporting packets from one blockchain to the other. So it's just sitting there listening now, right? Now we're going to actually try to send something across. All right. One moment while I do things that people shouldn't see over here. Okay. So Kepler is a Cosmos wallet, and so it can talk to lots of chains. And it can pick up new chains dynamically, which is kind of fun. So this is this wallet.agoric.app, which is just a web page. And when you hit this button, these are the chains that Agoric wants you to be able to use with Kepler. So Cosmos Hub testnet, I did this with configure. Oh, extension context invalidated. Oh. Reload the page. Install wallet. I already did this, so it could be failing because it's already done. Cosmos Hub testnet configured. And basically what that is it, if I hadn't already done it, it would basically ask me, are you sure? And that tells it the name and the chain ID and the RPC address. And so it sort of tells this extension how to talk to that blockchain, right? And then the other one I'm talking with is Agoric DevNet, and I hit configure. Oh, it hasn't done this. So requesting a connection. Wallet.agoric app is requesting to connect your Kepler account on, connect to your Kepler account on Agoric Dev 6. By approving this request, the website will know your wallet address and be able to request signatures for transactions. I approve. I guess I had only sent stuff from Cosmos, so I didn't have to do that end. So now if I go here and I ask it about Agoric DevNet, I don't have any build. Why isn't it showing me run? Oh, well, it should be showing me run because the staking token and the execution token are separate in Agoric. The run is a dollar peg stablecoin that we use for execution, and build is the staking token. Okay, but that's the destination chain. The one we're sending from is the Agoric, sorry, it's the Cosmos hub demo test thing like that. And the faucet is very generous. I just tapped the faucet once and it gave me a bazillion atoms. Or muons is what they're called for test. Okay, so here we have this. And we're going to do an IBC transfer. And the other end is going to be Agoric. Ooh, no, it's not Agoric stage. Okay, I was using Agoric stage earlier, but I want to use Agoric dev. So we're going to set up a new transfer channel. And the chain is Agoric testnet. Is that what it's called? All right, bail. Because testnet is usually something else. Agoric DevNet. Welcome, Ron.
Hey, Ron. Oh my goodness, it's 11 o'clock. We have a meeting with Ron and Rao, and we didn't get final word from Steve Talbot Ross as to whether he could make it this morning. So should we finish up quick, Dan?
Yeah, I'll just do Agoric stage. I've already got that. Let's do it again. So IBC transfers, the user interface looks like this, and then I've got an address where I was. Oh, this is the account that's connected to my the wallet where I was doing JavaScript execution, and so I can send it. Submit.
Why don't you give Ron a one sentence overview of what you're doing here?
Right, I am sending tokens between blockchains using a thing called inter-blockchain protocol.
Okay. RPC or how's that getting transferred?
there's a thing called a relayer that sits in the middle and listens to one side and shuffles the packets to the other side and vice versa.
Okay, thanks.
And it uses RPC and WebRTC and just about anything, I guess.
Yeah, this was the. It's got some HTTP ports and some WebSockets ports and stuff. What's
Yeah,
the
custom ports there? Yeah. Okay.
Yeah. What's the 11 o'clock meeting, Jim?
The 11. It's a what do you call it? A business planning for what we say. We're looking at how our chain is getting funded and stuff like that.
Oh, I think I will leave that to you guys.
And also, I guess we'll discuss the LCA structure. And, you know, I don't know if we'll have anything meaningful to say on that, but I'm sure Ron has some ideas on the corporate structure of the special purpose vehicle spin-offs of ArtChain. ArtChain's a wholly owned, or they're wholly owned subsidiaries of ArtChain at this point. There's two of them. There's Dazzle, and well, we'll get into that later.
That's it's a pretty cool chair you got there, Ron.
Thanks. The girls got it for me. Thought it'd be more comfortable.
Okay.
I don't have the console, you know, to go with it there, you know, with all the
Right.
thumbs that.
Right.
Yeah.
Well, I'm here in Kansas City. My name's Dan. I don't know if we've met. You're.
I'm in just north of Dallas, McKinney, Texas.
Oh, okay.
So,
Yeah, I
but,
know. I know Ron from the Team Human, Doug Rushkoff community.
Oh, really?
This is really his first introduction to ArtChain people. We want him to become a member and work with us, hopefully.
Great. All right. Well, you guys run along. I'm going to go do some boring documentation stuff. Enjoy.
All right. Thanks much, Dan. Let me stop the recording.